Okay, while you're finishing, I'm just going to go through things really quickly. Let's see. If you weren't here last time, I wasn't able to actually record. I usually record, so I put a PDF of the PowerPoint right here. You can go back over that, or down here at the very bottom, there's last year's, but I don't think I did the safety last year either as recorded. So just go back over the safety, and then there's a Nearpod that you go to, and that's part of the 7.1 assignment. So we're right here. I will put the lecture up underneath here so you'll be able to see it again, sort of like this one is, where a little bit, I'll actually move that up one because that is what we're doing today is the video and endoexographs. So we're going to go ahead and get started. The objective today is to use a reaction pathway, a graph, to distinguish between an exo and endothermic reactions. Now we're working with Utah Standard 4, Objective 2D. I know that just doesn't really sound exciting to you, but I have to keep track of the things that we learn. This thing basically says, after observing or measuring classifying evidence of temperature change in a chemical reaction as exo or endothermic, which is pretty easy. And then we're going to do some graph stories. A lot of the ACT, if you notice for the science section, is just reading graphs. Can you read the graph? It's not science. It's can you read the graph? So hopefully this practice with graphing and sort of thinking behind the graphs will help you on your ACT if you're taking it again in March as a junior. And then we've got some practice problems with your assignment. So if you'll get your packet out, we're going to start with 7.2 and some funny graph stories. I'm going to get one here so I can follow you along. So in your packet, we are right here, okay? And it looks like I am actually not where I need to be in the notes. Okay, well, we're going to skip this. We'll come back to work 2. Let's go to number 3. So it was 3. I skipped ahead from my notes, and I'm not prepared for you to do the lab, so we'll do the lab next time. So we're going to do daily work 7.3, and then we'll come back to 7.2 next time. Okay? This is what happens when you don't have the new one at home when you're preparing. All right, so we're going to talk about graph stories. If you look at your graphs here, you can see 2 graphs. One that, and I'm going to bring up a thing so I can show you really fast what I'm seeing. Hopefully if it wakes up. I'm thinking about it. Okay. So we have endo and exothermic graphs here. Bring it in. The graphs basically just tell us a story. We start with our reactants. We have to have some kind of energy. We get to the top and we have the products. Okay? This is the potential energy. That's what's on the y-axis. The x-axis is the reaction progress. So as we go to look at this, okay, we start with our reactants. We need some amount of energy. This right here is known as E of A. This is our activation energy down here. Let me slide this up a little bit. Okay, that distance from the reactants to the top of the curve is known as the activation energy. So from the reactants to the top of the curve. That's our activation energy. Our potential energy is shown on the y-axis. That's over here. So you've got colored pencils in front of you. So whoops, this colored pencil's not going to help me because it doesn't have any lead. So I'll use this. So I'm just going to help myself by saying this is potential energy, that's potential energy, so I can keep track of it. And then same thing with activation energy, so I know what each is. This right here at the very top of the curve, this is my activated complex. it's sort of like trying to figure out which way I'm going to go. Do I have enough energy to make it up over, or do I have to turn around and go backwards? So here, at the top of the curve, that's my activated complex. The reaction pathway itself is the path the graph takes. So I'm going to do this in blue. This is the actual path, path that it takes. It's actually following it all the way along. That's the reaction pathway, or the reaction progress. Where is it along this pathway? And this marker sucks. Okay, let me zoom out just a little bit because we're running out of what you can see. So I'll just put a little jagged line under here so you can sort of see it. That needs to be thrown away. Okay, and then the last one, delta H, is the difference in potential energy. You'll see me write it as PE. Maybe we should put that up here. This is also known as PE. Difference in PE of the reactants and products. So up here on the graph, I can actually read off the graph here what my reactants are and what my products are if I had put numbers on this graph and take the difference of them. That would be delta H. So here we're going to another color. Need to get me some colored pencils up here. That's the distance between here and here, products and reactants. That's my delta H. Okay? Now, I want you to take your colors and I want you to show me what's happening here on this graph. Just like we did on this graph, I want you to do it on the graph on the right. And I guess I should have put down here, we actually always take the products, the reactants minus the, reactants. This is going to be a positive. So products minus the reactants. To get delta H. Okay. When you get this one done up here, would you do the one at the bottom? It's down here. Also, because we're going to do something else with that, so have another color just hanging on for a minute. And I'm going to quickly do this one too, so don't look up unless you've got that top one done to double check and make sure you've got it right. Except I threw away my blue, didn't I? Oh, I found another blue. Whoops. Okay, how many of you did what I did with the E of A and then had to go back and fix it? I went all the way to the bottom line that was dotted. Remember, E of A is just from the reactants to the top of the curve, so I did a mistake because I was working too fast. All right, we ready? Did you have a chance to get everything colored? Different color, I guess it's purple. Okay, so let's talk about these two graphs. They're a little bit different. The products over here end up higher than the reactants, and the products over here end up lower. That means this delta H is going to be positive. Because it's positive, because I had to add energy in to get from the reactants to the products, I added energy in. This is endothermic, meaning I added in to it thermal, which is heat. This one over here, the products are lower than the reactants. So here, delta H is negative because I gave off energy. Because I gave off energy, this is exothermic. Okay, everybody okay? So down here at the bottom, where we go to what does negative delta H mean, that means that I have an exothermic reaction. If I have a positive delta H, that means I have an endothermic reaction. Exothermic gives off heat or energy. And endothermic takes in, I'm going to run out of room, heat or energy. Okay. Now down here at the bottom, you've got a nice little graph right here. This graph, we're also going to add what's known as a catalyst. A catalyst is like a matchmaker. Reason being, it gets two chemicals. Yeah, I should say gets chemicals because it can be more than two together and is not used up in the reaction. So it can be used over and over and over and over again. So what that means is it lowers the activation energy. What that means is you, instead of having this much energy I have to put in to get a reaction going, think of it sort of old school. Right now in America, we date till we finally find the person that we want to marry. In the old world, they had matchmakers. You would give the matchmaker your list of what you would like to see in a prospective mate. They would go out and do all the work and say, ah, I found someone. Now, if you've ever watched Fiddler on the Roof, it might not be exactly what you wanted, but the end product is the same. You're married. Okay, so this lowers the activation energy. Okay, so this right here is because of a catalyst. You didn't have to put all the energy out. You have to put a little bit out by telling them what you want to do or what you want to have, but you don't have to put as much. Now that line does not always have to be straight. So if I have another thing here, and here's my, I'll do an endothermic reaction this time because it can happen in either. Okay, maybe it's a little more like this. Okay, so it doesn't have to be a straight line, so don't get hooked on that being a straight curve. All right, you okay with that? Okay, flip into the next page. So calculating using delta H. So here now we have a graph, and I'm going to enlarge this so we can actually see it a little bit better. Here we have a graph that has numbers on it. And those numbers tell us how far it is from each. So what I want you to do is go ahead and start labeling for me what things aren't on this that were on the other side. So where do we start? What's this called right here? Reactants. This is where we start. So we're going to write reactants here. I'm going to keep that purple because it's really vibrant. Okay, where do we end? Products, right? What was the distance between the products and the reactants called? Don't be shy.
Reaction pathways/progress.
Okay, that is, the reaction pathway is actually this right here, this actual pathway that we go. That's the reaction pathway.
Delta H.
It is delta H. Is this delta H positive or negative? You have to put, good, it is positive. All right, what is the distance between my reactants and the top of my curve called? You remember that one.
Activation energy.
My activation energy, good. And then at the very top of the curve, what was that? That's my activated complex. That's the way I can go either way, forward or back. We know that over here is our potential energy. Now, knowing that, we're going to look at each of the questions. So it says, what is the enthalpy of the reactants? That's like saying, I want you to put underneath there PE. What is the PE of the reactants? So the enthalpy or potential energy of the reactants, what is it? Read off the graph. What do we got? Where do we start?
20.
20, yeah, so we're going to put over here 20, and we're going to put a kJ next to it, kilojoules, because kJ tells me how much energy, kilojoules. Okay, the next one is what is the enthalpy or PE, potential energy, of the products? So again, looking at our graph, our products are right here. They did such a nice thing by doing the dotted line so we can easily read it. What's that number?
50.
Thank you. You guys are helping me because that's really tiny on here. And the units here would be kilojoules. Even with my granny glasses on, sometimes I can't see that. Got to get stronger ones. Okay, the next question is what is delta H? So here we've got the difference between our products and our reactants. We know it's going to be positive. So what's the difference between where we started and where we ended in a positive thing? Because we had to put it in.
30.
30. It's the difference between the 50 and the 20. So it's positive, and we have to write the positive, 30 kilojoules. Because that positive tells me I put that energy in. Well, if I put it in, is this an exo or endothermic graph? Endo. I put it into. Not, it didn't exit. I put it into, so I'd say it's endothermic. All right, so I'm going to do this next part right here. You're going to do as your practice here in a minute. So just ignore it for a minute. We're going to have some fun up here on the board while we do some silly graphs. Okay? So, funny graph stories. Cat versus hotness of a girl. What do you think should go on each? What should go on the x-axis? What on the y-axis? Make a silly graph. Come on. Cats or hotness of a girl? Which one goes where?
Does it matter?
No, choose. That's what I'm saying. Choose. We're going to make our own graph up.
Cat goes X.
Cat goes X. Okay. So I'm going to put my cat here, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, hotness of the girl then would go here. Okay, so 0 to 10 maybe, with a 5 somewhere in the center. Okay? All right, so give me some ideas. What would this graph look like? Like this. What would it look like? It could be anything. There's not a wrong answer, so shoot something out. Where do I start at 0?
Y-axis.
Yeah, but where? What number? on the x-axis or y-axis. If I start at 0 on the y. 5. Okay. I'm gonna start here. Now I have 1 cat. Where am I?
6.
Okay, 6. Okay, and I have 2 cats.
5.
Back down to 5. Okay. If I have 3 cats. 2. Oh, whoa, we really dropped it 2. Okay, 4 cats.
1.
To 1. Now 5 cats.
7.
Oh, we're going to 7? All right. She wants the graph to look crazy. Number 6.
3.
Boy, we're jumping all over the place. Okay, somewhere in there. Okay. 7.
4.
2. 2 and 4. Okay, between is 3. 8.
10.
A 10 for 8, huh? Okay. And 9?
1.
He's like, I'm going to get this in here. All right, so our graph looks like this. So trending, not very great, right? Well, all right, let's leave this crazy cat lady and move on to a different one. So mental health versus the amount 1 to 32 we have of teeth. So we have 2 different lines on a graph that are not related to each other. So mental health versus teeth and mental health versus number of cats. Okay, so we're going to have 2 different lines on there. So we can put mental health on this side maybe. How are we going to rate it? 1 through 10, meaning what's 10? Is 10 total great health?
Yeah.
So this is good, and this is bad. Okay. And then along the bottom, we'll put number of teeth versus number of cats are also going to be on the bottom. And it's 1 through 32. Okay, so here we go. You have 1 tooth, 1 cat. Where's your mental health? Well, let's do this. Let's do cats first. So 1 tooth, 1 cat.
1 tooth would be like at the bottom and 1 cat would be in the middle.
Well, you've got a side. So over here, this is mental health, and we're just doing cats first. We're going to put 2 graphs on top of each other. Okay, so we're just doing the first graph. So mental health versus teeth.
1 would be at 0. Yeah.
Think of 0. Okay. All right. And let's skip a couple. Let's go to 3 or 4. Teeth.
2 maybe.
2. Okay, we'll put it somewhere in there. All right. Let's go to 10 teeth.
3.
Okay. Let's go to 15 teeth.
7.
Okay. Let's go to 20 teeth.
8.
Let's keep crying. Okay, let's go to 25 teeth.
8.5.
8.5, really good. Okay, let's go to 30 teeth.
10.
10, okay, and 32 teeth?
10.
All right, so this is the graph for this one. This is teeth. And I don't have a different color, so we're just going to do this because in this program it'll only let me do 1. Okay, so now we're going to do the number of cats again versus mental health this time. Okay, so 1 cat or 0 cats first. Oops.
10.
0 cats is a 10. Okay. 1 cat.
9.
No mental health?
Oh, 9.
Oh, 9. Oh, I thought you said none. I was like, oh, wow.
Yeah, they don't have much.
Okay, let's go to about 5 then.
5.
5 cats.
Yeah.
5. Okay, 10 cats.
Like a 2.
A 2. Okay. And 15 cats.
1.5.
1.5. Okay, and 20 cats.
You're gone.
You're gone, okay, down to 0. And 25, still 0?
Yeah.
Okay, going across at 0. Okay, so I'm going to do a wiggle on this line so we know which one's which. This is our cats versus crazy. There's a point where they come together, right? Yeah, it's not real great on the scale that we've got for mental health, right? But they do converge. All right, let's look at another one. These are just silly ones, okay? Time versus urge. 2 different lines on the same graph. Need to pee, need to sneeze. Okay, so this time we're going to put time along this graph. And we'll just go 0 to, say, 2 hours. And over here is going to be need to sneeze and need to pee. 0 to, oops. Okay. All right, so what does it, how, let's do the need to sneeze first. You just all of a sudden, chew. Sometimes, most of the time it's like, oh, okay, all right. Okay, all right, right? So it's more like this. It's more like, oh, chew, and it's there, right? Okay. Well, what about the need to pee? Isn't it about the same, sort of? Maybe it's over a longer time. Okay, I need to. Okay, I'm holding it. Oh, I forgot. Oh! What happens at these points? Oops. So they actually go over. If any of them have happened to be at one of these need to pee, need to sneeze at the same time, reaching a peak, we're really in trouble, right? Okay, just funny, different, weird things, okay? Where they meet is a disaster. All right, so, come on, it's not, there we go. All right, so really quickly, reviewing a fast thing again. Doing this really quick, we have our activation energy here to here. We have delta H here. Is it positive or negative?
Positive.
Try not to look down at your paper. Right, positive. What's this point right here called? Activated complex. Top of the curve, activated complex. And then I would read off my potential energy over here, right? On this one, it's a little bit different. I got to be careful because if they've given me one dotted line, don't just grow to it, right? I say, oh, I start at my reactance and go up to the top of the curve. That's my E of A. My delta H here is it positive or negative? Negative because I'm going below. I'm getting rid of energy. So it's negative. Okay, this up here is called what again?
Activated.
Right. I'm just going to do AC, but yeah, activated complex. What is this graph over here on the left? What kind of graph is this? Good. It is endothermic. Just remember, thermic means heat. Endo, I'm putting into. So it's sort of like endo into. Okay? What about this one? Exothermic. Good. Oops, I cannot spell. Let's try it again. Exothermic. Exo meaning it's exiting the state. Exotherm, I forgot the M. Okay? Leaving the system. And of course, following the pathway itself is the pathway progress. Right? So, I can still put on this graph everything I did on the others, right? I can say this is what type of graph? Exothermic, good. See if I can spell it this time. Yes. All right. Delta H, positive or negative?
Negative.
Negative. What's this again? See, I'm going to get you having this. Activated complex. Okay. what would a catalyst look like? Lower, anything lower. You can put anything in here that's lower curve. I could put one that I'll do a wiggly. Okay, I could do something like that. Anything that's below the original, that's a catalyst, what a catalyst does. It lowers the activation energy. So just remember, it lowers activation energy. Okay? Here's again, on the test, you will be labeling one of these. So as long as you label all the parts, you're going to get points. Okay? This will have numbers on it, and you'll have to actually give me what the numbers are for the different things. Yes?
Will we have like a word bank?
So this will be a written part of the exam.
Okay, so we need to memorize all the.
Well, but you just did, right?
Yeah.
So we're going to be practicing on them. So by the time you get there, should be no problem.
Okay.
So you'll have practice on them on your quizzes every day. Okay, so you'll see these graphs a lot. All right, so looking at graph now, we have numbers. What's the enthalpy of the reactants? I'm not going to label anything. I want you to tell me what it is. Don't look down at your notes. We're just up here now.
20 kilojoules.
It's what?
20 kilojoules.
Good. And you got that right here, right? Because this is where my reactants are. So I use this to answer this question. Okay, what's the enthalpy of the products? And remember, enthalpy, we wrote in our notes, another word is potential energy. So if it's labeled potential energy, just know that's the same. So what is it?
50 kilojoules.
Good. This right here, this is my products. Okay, what is the delta H?
30 kilojoules.
Good. The distance between my products and my reactants, and it is a positive, so I'm going to put positive 30 kilojoules. Is this exo or endothermic? Good, because my products are higher. I'm just going to circle it. Then my reactants. Now, I'm going to ask you another question we haven't answered before. What is my activation energy? What is my activation energy?
100 kilojoules.
That's my activated complex is 100 kilojoules.
80 kilojoules.
80, good. I have to go from where my reactants were up to where my activated complex is. That's my E of A. So the distance here is that 100 minus the 20, which gives me 80 kilojoules. Okay? Understand it? Awesome. All right. So now you get to draw your own graphs. Put some color into them. Label as best you can. And then make sure you upload everything. If you haven't uploaded stuff from last time, make sure that you do upload it. If you've got questions, make sure to ask me and I'll come over and help. Or ask your neighbor. Have them read your graphs, pair share, and see if they understand what you did. Okay? Any questions? All right, time's yours.